right. Well, welcome back. What we're going to go through is we're going to go through some various problems on how to solve for exponential and logarithmic functions. We're solving for x. Solving for x, just make sure you do inverse operations. That's the key thing when you're doing any type of equation solving. So without further ado, let's go through some examples. What I have here is example number 1. Where we're going to solve for an exponential function. So first identify what you have. Now, in order to solve for an exponential, we are eventually going to use a log. However, we have to isolate the exponential by itself. So we're going to isolate the exponential by itself. So to do that, we're going to divide by 14 both sides. All right. We're going to have 560 divided by 14. All right. Now, if you're not sure what 560 divided by 14 is, you can calculate it right here. All right. And all right, we'll go right here. 560 divided by 14. See if that turns out to be a nice number. And the answer is 40. All right, it does turn out to be nice. So we have that. All right, so we're going to have 40. So 40 is going to equal e to 3x plus 2. Now you can notice that e to 3x plus 2 is all by itself. Right? There's no negatives, there's no additions, there's no other things. So what we're going to do next is we're going to eliminate e by logging it. Okay, good. The log we're going to take is the base of e. So that means we're going to use a natural log. I'm going to natural log both sides of this equation. By doing so, I can use an inverse property, which allows me a function composed of its inverse. All right, we'll cancel out. We're left with the value inside, which in this case is the exponent. And so we have this right here. From here, we're going to solve this. And we can subtract 2, so we have natural log of 40 minus 2. Now make sure this is by itself. And then this equals 3x. And then solve for x. X is going to equal the natural log of 40 minus 2 divided by 3. If you did put that in your calculator, all right, just make sure that you are, oops, wrong button, sorry about that. All right, then when you're plugging that in there, you go natural log of 40, close parentheses, minus 2, and if you want to press enter, you get one of these handy calculators, press enter, you get that answer, and then divide by 3, and what we have is the answer of 0.563. 0.563, so 0.563 would be our approximated answer. All right, let's try another one. That was using logs and solving for exponential functions. So let's try this example number 2, and let's solve this logarithm. Now, in order to solve for logarithms, you have to go through the same thing. You have to get the logarithm all by itself. In this case, it is. The next thing is now, in order to solve for a logarithm, you have to use the inverse property. The inverse property in this case is going to be, all right, well, the base is going to be an exponential. And so what we're going to do is we're going to raise this to the power or the base of x. So right here, I'm going to x log base x of 6.5, and then x right here. What happens is, once again, inverse property. These will cancel. We're left with 625, and that equals x to the 4th. Now, when we have this, we're going to now take the 4th root of 625, and that equals x. And when you bring the 4th root, you bring a plus or minus. However, you have to know that when you have a log, the base has to be, all right, greater than 1. All right, or it can't be negative. Just put it that way. All right, it cannot be negative. So what we have right there, right, is going to be simply the 4th root of 625. Can't write today, which equals 5. There we have it. All right, we went through 2 examples of how to solve exponentials and logarithmic functions. With easier examples, we're going to get some harder examples in the next 2 videos. So I hope this helps you out, get you started. So go and God bless them.